Well, good morning, everybody. My name is Kerry Forster. I'm the Chief Executive of the Workboat Association. I'd like to welcome you all on behalf of the Commercial Marine Network, in partnership with the Maritime Journal and Seawork, and in association with the Workboat Association. And we're pleased to be supported by the Society of Marine Industries. I'd like to express our thanks to our Session 2 sponsors, Southerly Designs, a company who have been at the forefront of aluminium vessel design for over 2 decades. Southerly have over 40 years experience in designing, constructing and operating fast commercial vessels and have forged an inviolable reputation for producing robust vessels that are practicable and known to handle well in extreme conditions, are fuel efficient and offer comfort without sacrificing performance. This is the second in our series of events, and today's theme focuses on the short term from 2020 to 2025, including re-engineering and refitting the fleet, improved technologies for engine efficiency to decrease emissions, including Tier 3 diesel engines. So thank you to Mercator Media, the Seawork, Maritime Journal and Commercial Marine Network teams, and thank you to all of you 240 registered attendees for today's session from wherever you may be joining us today. We have some great speakers whom will be introduced to you shortly by my colleague Andy Page. And before I introduce you to Andy, there are some functionality topics to discuss for today's session. So we'll start off by letting you know that today's session is being recorded. There is a public chat function available to use throughout the session, which we welcome delegates to use to make any introductions and comments. But please do not use this chat function to ask questions, and I'll explain why shortly. There is also a private chat function, so if you're having any issues or comments for the host, please use the private section of the chat function, which allows you to send direct messages to specific people, and the admins for today's session will be listed here. There's a questions and answer section. We'll give the opportunity for delegates to ask questions to the panel at the end of the session. This feature is found next to the chat function, and please type any questions here throughout the event, and our moderator will read these out to you at the end. If you're directing your question to a specific speaker, please ensure you include the speaker's name in the question. If you're joining from a mobile phone or tablet, please note that the chat function may be hidden, but can be accessed by clicking on a blue speech bubble icon. And finally, following today's session, will be a swap card networking session, where attendees can register online and book one-to-one meetings with speakers and other attendees. Those wishing to sign up for this session need to follow directions that will be shared at the end of this panel session. It's important to those who want to be part of this to get online and start booking your slots as soon as possible. So I'd like to introduce you to today's moderator, Andy Page from Chartwell. So Andy, I'll hand the session over to you, and I wish everyone the best of luck.
Thank you very much, Kerry. Welcome everyone to today's session, the second session in our series of events. As I say, thank you to Kerry and thank you to Mercator Media for organising our second event today. It's great to have so many participants with us. As Kerry mentioned, we have 3 great speakers on the session today, with today's focus being the re-engineering and refitting of the fleet. So in order to support this, our speakers today are providing information on their experiences and their plans going forward. Today we have 3 speakers, as previously mentioned, starting with Andy Osborne from the Port of London Authority, Cedric Mevier, who is representing Cummins Europe, and finally Owen Priest from Bureau Veritas, who is speaking on behalf of the Classification Society and the UK Certifying Authority. So first up today, we have Andy Osborne. So Andy, if you could turn on your camera. Andy's background is, he is currently the Marine Engineering Manager at the Port of London Authority. He started his engineering career in 1990. He started as an electronics design engineer working for Marconi Radar. Moving on from this, Andy joined the Port of London Authority, and his specialist subject is marine electronics, both on afloat vessels and on land-based equipment and projects. In recent times, Andy's focus for the PLA has been its future fleet and how this can be developed in line with green credentials. Today, Andy will be talking about the vessel-based work that the Port of London Authority are undertaking with their ambition to achieve net zero. He will be looking at some of the challenges they have encountered to date and some of the things that they anticipate along the way, looking at different technologies being used across the current fleet and how they're going to push this into future vessels. So, Andy, without further ado, please, if you can put your presentation up, and thank you very much.
Okay, thank you, Andy. As Andy says, I'm Andy Osborne from the Port of London Authority. I'm the Marine Engineering Manager. Okay, the Port of London Authority, for those people that don't know, we are a trust port. We are the custodian of the tidal Thames. And although historically we had all the docks under our control and all that side of things, these days our remit is around safety for commercial and leisure users and to enhance the Thames, improve the environment and those side of things. That covers from Teddington right out to the estuary, 95 miles of tidal Thames and 400 square miles of area. So we're one of the physically biggest ports in the country. We have a fleet of 30 powered vessels, ranging from this sort of 5-meter power cats, which is the bottom right image, with 40 horsepower outboards, right up to our salvage vessel, London Titan, in the middle of the image, which has 3 1,000 horsepower engines and weighs in at 680 tons, and everything in between. So quite a diverse fleet. We cover activities including pilotage, survey, harbour patrolling, salvage and driftwood collection across our fleet. That includes the use of 41 different diesel inboard engines, 11 diesel generators, 10 petrol outboard engines and equipment from over 13 different manufacturers. We're not tied into one particular manufacturer. Our current challenge is often around carbon. In 2019, we produced 1,916 tons of carbon, 81% of that being from our vessel fuel. Sorry, my screen's just, thank you. Our aim is to reduce this, and we currently have a target to drop our baseline of 2014 by 60% by 2025, which is quite a big challenge. Our board have also given us an even larger challenge of reaching net zero by 2040, which is 10 years ahead of the official deadline. So I have quite a lot of work to get onto, unfortunately. We have one of the first air quality strategies for the Thames, which has set quite challenging targets for the whole of the Thames. So we're doing all that we can to actually work towards that. And very recently, we introduced a new Thames Green scheme. We're trying to encourage the river users to adopt early adoption of technology to improve the emissions levels on the Thames. Well, we also last year did a quite extensive roadmap exercise. We got a company in called E4 Tech, who are consultants, and we collaborated with lots of other operators on the Thames to actually look at what technology might be possible and when that might be possible to bring it in place, you know, cost-effective ways and actually what's available to purchase. We covered a whole array of different types of vessels, from pleasure boats to tugs to small workboats and everything in between. It showed that there are some things that you can do now, and some things are just completely impractical right now. But at least we have a plan of where we're going to go with that, and so do they now. Over the years, the PLA has always invested money in lots of things. Being a trust port, we're not a profit-making organisation, so we invest back into the river. These include the top left is the Maplin server vessel. As you can imagine, with a river so large, we need something that can survey quite quickly. So with a 60-degree beam surveying angle for multi-beam, the image below is the kinds of images you can achieve quite quickly. And periodically, we go and survey the whole river. The bottom left image is our harbour service launches with low wash, designed in conjunction with University of Newcastle. We have 4 of those to try and back then to try and reduce the amount of fuel that actually burn. And the top right image is our hybrid vessel Leader, which is our latest pilotage vessel. One of our biggest uses of fuel was in pilotage transfers because they run 24/7, 365. It doesn't matter how little fuel you use, you're always going to use a lot doing that. So she is battery powered and diesel engine powered together to both produce a hybrid vessel, and she can save up to about 60% of fuel. We've actually seen some quite good results of that. We've also installed a engine monitoring system on virtually our entire fleet now, so we can see exactly what each vessel is doing each day. Every day that they run, we get a report that shows where they've been, how much fuel they've used, what kind of revs they were doing at the time. We can see the fuel profiles. We've been using this quite a lot to actually work out what can and can't be done, whether it's a change in operational use, whether the boat is dirty and needs to be cleaned off of the hull to actually make it perform better, whether it's got an engine problem. We get early warning straight away, so that's been quite a powerful thing and quite a strong investment. More recently, we've been looking at various alternatives to what we can do. We obviously the net zero challenge and the carbon challenge has been there for some time, only more recently announced. But we've been looking at alternative fuels. Our harbour service launch Q has been running on a green fuel, HVO-based green fuel since July last year, and we've clocked up 3,300 hours on each of those engines. We've recently, these are John Deere 6068s, 6.8 litre 6-cylinder straight engines, and we recently took one out and stripped it down. There were no visible signs of concern. It all seems very clean and tidy, and we've had no actual loss of power, no breakdowns, no block filters. Even though we use quite a lot of stages of filtering, we haven't had any clogging, no injector issues. So we're so far with this engine and that fuel, we're quite confident that it's working well. The plan is with that to flow that fuel out through the rest of our fleet on a gradual basis. We have come up with a project to de-risk that exercise, if you like. So we've got a time schedule that shows where each of the vessels sits in that, and we're going to try and fit secondary tanks on each of our fuel delivery sites, so we can run red diesel and green fuel, if you like, for each. So we can actually use some vessels on each, and gradually work our way up to our most expensive engines that obviously we don't want to risk unnecessarily. Another project that we've been working on is in partnership with the Cross River Partnership. We were successful in a bid for Clean Air Thames to fit a selective catalytic reduction system to one of our vessels, which was Driftwood 2. She's 30 years old, running Caterpillar 3306B engines, well below the tier system back then. These next images show the plan is to actually take out the silencer, which takes up quite a lot of space, and stick the main SCR housing in that space. There's quite a lot of electronics that goes with this because of all the sensing. I think that is on the next slide. No. Yeah, so this is an overview of how that looks put together. So you've got sensing either side of the SCR to actually monitor what's going on, to work out how much dosing you actually apply. So there'll be control cabinets fitted in the engine room. There'll be an AdBlue tank fitted in the engine room, and the idea is that we're going to stick an AdBlue IBC with the fuel, so they can actually take AdBlue on at the same time. And the diagram, which is a bit scruffy to the right, shows the engine room for the two engines and the exhaust systems jammed in. The silencers will have to be replicated further down the line. So this really is a kind of a squeeze it all in scenario. As I said, we've always tried to push forward with doing the right thing. We're quite a green company. We have an environment team, and we have a lot of directors from the board and from our executive committee to actually do the right thing. So at the moment, our entire fleet is at tier 2 or less. We would like to invest in some tier 3 or higher engines, but we haven't. There seems to be very little out there to choose from. Typically speaking, vessels are built around their propulsion systems. When you build an engine room, you stick an engine in it, and it's never any bigger than it needs to be. And a lot of these technologies, the newer engines and things like SCRs and DPFs, take up an awful lot of space, and there's just nowhere to stick it. So we need to get beyond that if we can. We can't afford to just replace our entire fleet, and the timing to do that would be incredible. In my opinion, many of the engine providers don't seem to be focusing that much on the small commercial fleet. There's some of the tiny stuff out there. There's some of the bigger engines out there, but we operate between sort of 4-litre and 32-litre engines. We've got a whole array, and there doesn't seem to be an awful lot out there to buy. So I welcome anyone coming forward with that. I think most operators would welcome a slot-in alternative, that would go straight back on the engine mounts, couple up with the existing gearboxes, be at the right engine revs to actually match in with, because you don't really want to have to replace everything as part of that exercise. Another challenge is also if you have a wet exhaust system, because the water injection is going to be potentially too far down the line. And after you fitted in the exhaust treatment systems, it may not line up properly with your vessel. So what happens next for us? We're always looking at investing in further solutions. What we found probably more important than anything of late is the collaboration side of things. So we want to work with other people. We want to learn from each other's experiences. On the environmental side, there's not a lot to gain from keeping secrets. If we want to sort out this emission problem, then we need to share ideas, good and bad. Let's look at the challenges we've had. Let's look at how we got beyond those problems. Work together. Always monitoring technology developments. There's always new things coming out, new ideas. Some of them are in the early stages. Some of them are ready to go. But welcoming people to come in, and we have more challenges than we have solutions right now. So I welcome, as a company and as an individual, people to come to me and say, "We've got this. We can do that. What about this?" Yeah, thank you. That's me really. If there's any questions.
Yeah, thanks very much, Andy. I just got just one quickly, and then we've got a few at the end of the session, which we'll have in a panel discussion. With respect to the vessel monitoring system that you fitted, have you seen operational changes since fitting and analysing that data?
Some of that, definitely, yes. We can feedback quite quickly if people are driving unnecessarily quickly for what they're doing, or if we've found optimum parts of the operational curve, if you like. So when vessels plane and when they don't, you can see exactly how much fuel is used, and we can go back and look at all the historic data going right back to day one. For our 2015, we can look every day and compare that data. So definitely you can use that information quite powerfully to actually adjust what you do, which is half the battle, really.
Exactly. I think it's really important because if you're going to fit new systems to reduce emissions, or you're going to change your fuel type, having the pre-data to see what you were doing before is very important to justify what you're doing now and in the future. Great to have fitted that system, and I'm looking forward to asking many more questions later on in the session. So,
okay, thank you.
So our next speaker today is pertinent timing, really, as per Andy's comment there about engine manufacturers and perhaps not necessarily focusing on small craft. So hopefully Cedric is going to tell us otherwise and explain what Cummins have to offer. Cedric Murier is the European Sales Director of Cummins Marine. He holds 15 years experience in the marine industry, working alongside European OEMs and shipyards to define and integrate diesel engine solutions. He has a passion for customer satisfaction and the integration of new technologies and innovation. Today, Cedric will be presenting and advising on regulatory emission standards, how they vary region to region, what challenges lie for engine manufacturers, shipbuilders and their customers. He'll explain IMO Tier 3 and how the rule applies and how manufacturers have to decide between reinventing the wheel and making modifications to already proven technology. Cummins is taking their proven dual-tier approach used for IMO Tier 2 engine technology, adding a proven SCR catalyst, and then looking at trying to give operators the flexibility to run IMO Tier 3 sometimes and IMO Tier 2 other times. So I'll hand over to Cedric to explain more, and then we'll take questions in the Q&A panel. Thank you very much.
Good morning, everyone. Thank you for the opportunity to present during the session 2. It's quite important topic these days about emission regulations and emissions reduction. And Cummins has always been a pioneer in leading in emission solutions. And we do have some integrated solution for our marine engines. And I'm going to present to you what we can offer as an engine supplier. So I will start looking a little bit at the history, what were the different timeline in terms of IMO regulation from Tier 2 to Tier 3. I will present what we offer today as a combined system to install with our high-speed diesel engines, and then 2 different case studies for hybrid application. One is a ferry in Norway, and the other one is a US vessel that features an hybrid system. So IMO Tier 2 basically was set effective in January 2011. The IMO Tier 3 came into effect in 2016, and this started in North America and Caribbean waters, and North America does include Canada. It was looking at the SOx and at the NOx. And starting January 1st, 2021, we will have new emission control areas in Northern Europe, which is the North Sea and the Baltic Sea, as well as the English Channel. So when traveling into these emission control areas, the vessel, they must meet IMO Tier 3, and there is some specific as well about the fuel, that there is a sulfur cap of 1000 ppm. Looking at the reduction of NOx between Tier 2 and Tier 3, there being a 70% reduction limit on the NOx emission, which is now set at 2 grams per kilowatt hour. and compared to other regulation that we see in the US, in the case of IMO 3, this is the operator, the end user, who is responsible for the compliance with IMO 3. So how do we achieve IMO Tier 3? So what we decided to do at Cummins is to use the latest modular common rail engines, which are IMO Tier 2 compliant. We started to develop that range back in 2005. We take an engine which is a Tier 2 engine compliant, and what we add is a SCR, so selective catalyst reduction components, which are type approved by the major IACS classification society in order to get a IMO Tier 3 package. So looking a little bit in more details at the SCR system, it uses a mixing tube where all the exhaust engine gas will enter. There will be an injector unit that will spray AdBlue or urea to separate the NOx molecule. And then after, the gas together with the urea will enter a catalyst, which is comprises of catalyst bricks of vanadium, and that will recombine the atoms into different molecules, which are CO2, N2, and water as well, for cleaner emission solutions. That system is very low in creating back pressure. It's only 1 or 2 kPa of back pressure. So it means that we can allow installation on dry exhaust system or underwater exhaust as well when there is a water injection in the exhaust system. We do provide a warranty of 2 years on the SCR system. And what we offer to customers, which is something important, is a Scheme A certification, which means that we deliver all the package together with the certificate for IMO 3. So there is no onboard testing to be done. This has been done at our factory in the UK and in the US, so we can demonstrate IMO 3 compliance. So as I said earlier, when vessels are not operating in IMO 3, the system can be switch off, turn off, and the propulsion system auxiliary genset will operate on IMO 2. So this is an example of a hybrid ferry, which is featuring 4 QSK50 auxiliary generator sets. That ferry has a 500 passenger capacity and 200 cars. It has a big battery bank of 1200 kilowatt hour that permits to run the auxiliary generator set on the best brake specific fuel consumption to optimize fuel consumption, and as well to reduce obviously the engine not running completely loaded, to reduce the noise and the vibration. That ferry is one of the first projects that we did with IMO 3 on our QSK 50 engines. Each engine is 1400 kilowatt. It will be operated in Norway, and you can see some pictures of the installation. So we have 2 engines on each side of the vessel, and the SCR system is up here, so it doesn't take any space in the engine room. Another example, which is a little bit different, this is Harbor Harvest catamaran running on variable speed diesel electric engines. So we do have in our range engines that are C1 emission compliant for variable speed diesel electric application. This is quite a high stake example because it it's used to move food from the farm to the table, where it would take 9 to 12 hours by truck, whereas with a ferry, they can make the trip in 1 hour. It can run 100% on electric, and it has an autonomy of 20 miles. So the way the system is designed, this is what we call a series hybrid, means there is no mechanical connection directly between the engine and the propeller. There is the engine, it uses integrated starter generator that will produce AC power. Then an inverter will convert this into DC, and there is a power control system that will give power to the traction motor or the electrical engines. Thank you for your attention.
Great, thank you very much, Cedric.
Any questions?
So I think perhaps just one for now and then some more later. I just wanted to ask, with respect to the switching between tier 2 and tier 3, when might that be appropriate? Perhaps when you're doing like a long passage outside the UCA area, or?
Can you repeat, Andy, because you broke up at the beginning? Sorry about that.
Apologies. You mentioned the ability to operate tier 2 or tier 3 on the engine system. Where might that operation be applicable? Is that on a long passage, perhaps, when we're outside of the ECA area?
Yes, exactly. I would say the ECA area you can run on IMO tier 2 with a higher sulfur content as well, which is set at 5,000 ppm. So it's just a matter to turn off the system, basically. However, the system is still monitored because you can have some risk of carbonization buildups when you run too low on load. So the system is still monitored. However, it's not used, so there is no dosing ejection. There is a cleanup that is being done on the injector, basically to maintain the system in good operations, but there will be no consumption of DEF or urea in that case.
Great, thank you. I think we'll probably expand on that a little more later on. Thank you very much, Cedric.
Thank you.
So our next speaker today is from the I guess from the regulator, as it were, or a classification society, who in the case of the UK works on behalf of the regulator as a certifying authority. Our presenter is Owen Preece. He is representing Bureau Veritas. BV is a large IACS classification society, and Owen works both in the technical and survey section within the UK and Ireland new construction management title. He is responsible for all aspects of vessel survey, technical work and certification. Also, with respect to small craft, Owen is responsible for the workboat fleet in the UK and has been involved in the development of regulations such as the HSOSC code, the update of the workboat code, and he continues to input into these forums, working closely with regulatory authorities. Today's presentation will focus on sustainable shipping and how Bureau Veritas are involved in working with clients to comply with regulations to improve their ship performance across the industry. And to support that, Owen is going to give us a high-level overview and try to focus on his experiences in the UK market and how it's relevant to the workboat sector. So, Owen, if I could hand over to you. Thank you very much.
Thanks, Andy. So I'm just going to quickly touch on the environmental regulations that have come into force and are due to come into force in shipping running up to 2050. Now, I know a lot of these regulations don't necessarily apply to non-conventional vessels such as the UK workboat fleet. However, obviously there are regulations such as Tier 3 that will impact the UK fleet. Along with this, the IMO are bringing in CO2 emission reduction targets and greenhouse gas emissions targets. The first one being a CO2 reduction of at least 40% compared to the 2008 figures by 2030. And then following that, a reduction of total annual greenhouse gas emissions by at least 50% by 2050. And included within that is a further CO2 reduction of 70%. So I mentioned obviously at the start that a lot of these regulations only apply to convention vessels. But I think one thing we should all remember is that we are also working towards the UK Maritime 2050 plan. So the regulation itself might not directly apply, but collectively, I think we're all working towards the same goal. So just a very quick background on Tier 3. I'm sure most of you by now fully aware. Let's quickly run through it. So Tier 3 comes into force on the 1st of January 2021. And essentially Tier 3 is a further reduction in allowable NOx emissions for vessels with an engine power output over 130 kilowatts. And it's approximately a 75% reduction over the previous Tier 2 limits. So as with some of the Tier 2 engines, fine-tuning engines is basically no longer enough. So as Cedric ran through, a lot of the manufacturers are looking at using additional technology and hardware to basically meet the Tier 3 limits, SCR systems, EGR systems, and other water injection methods. So each Tier 3 engine has to be supplied with an EIAPP certificate and technical file. So that technical file has to include any additional hardware that's been utilized in order to make that engine compliant. And one of the common problems is that there might be multiple parties involved. So you might have a supplier supplying the SCR system separate from the engine manufacturer. But for the actual EIAPP certification, it has to be handled by a single party. So one party has to take responsibility for that. So as I briefly touched on, there are a number of different solutions that can be utilized for overall emissions reduction and sort of general vessel efficiency improvement. So I've listed some of the technologies and solutions that BV have been working on with various owners and operators. What I'm going to do following this is just briefly touch on some of these technologies that we're coming across. But some of these technologies themselves are not sufficient to meet Tier 3. They have to be used in conjunction with other things. And just on that, obviously, although we're talking about Tier 3 compliance, we're seeing a lot of operators who need not comply with Tier 3 due to the vessel build date, but they're looking to reduce their emissions and increase their vessel efficiency, essentially through voluntary compliance. So one of the most common options we're seeing uptake of is hybrid systems, particularly in the new build sector, but also in existing vessels. We're discussing retrofit options with a number of owners. And BV have an electric hybrid class notation, which covers all of the requirements for installing and running a hybrid system on board. Now that covers both the operational side, but also the safety aspects with installing battery banks on board. So essentially there's 3 different hybrid modes that are covered by our class notation. The first one being what's known as PB mode, which is power backup mode, where the energy storage system, or ESS, aka the battery bank, is permanently connected to the main electrical power distribution system and is able to deliver power immediately in case of a failure of one of your main generating sets. The next option is ZE mode, where the ESS is temporarily the only source of power. But this could be either house load, so it could be general services on board, or it could be propulsion, or it could be a combination of the two. But essentially, when you're in ZE mode, there are no combustion engines running. So ZE is obviously zero emissions. The final one we have is PM, or power management mode, where you have a system such as load smoothing, peak shaving, or enhanced dynamic mode. Now, as I mentioned before, battery systems on their own are not necessarily or are not sufficient to meet Tier 3 standards without also having a Tier 3 compliant engine. But I think for a lot of owners, it's a good long-term solution because it allows flexibility. As battery technology improves, they can increase and extend that battery range. We're seeing a reduction in engine hours, maintenance, fuel burn, and obviously there's also the flexibility of the setup of the system because it can be set up in many different ways. You can have a conventional diesel electric where the shafts are electric motor driven. You can have direct drive with an inline electric motor that's also an alternator. So you have a greater degree of control over issues such as weight distribution as well. So we've also developed a battery system notation, which basically considers the use of batteries as the main source of power for either propulsion or house load or everything. Part of the requirement, as I mentioned before, considered within the hybrid notation. This notation considers a battery system as a whole and includes, but isn't limited to, the charging system, the support system, power management system, power conversion, and the battery management system. So basically any batteries fitted, including the battery management system, are to be type approved. And then a failure and risk analysis is also submitted and obviously reviewed by us. And again, I think we've had quite a lot of interest in this particular notation. Initially, more on retrofit projects where short sea vessels can utilize existing infrastructure to run on battery power alone. So the next notation, again, which is relatively new one for us, is the ULEV notation, which is ultra low emissions vessel. This has been again introduced following an emission reduction demand from owners and operators. The notation for this is actually assigned to the vessel as opposed to, say, EIAPP certification, where it's actually the engines. So as you can see from the table on the left, ULEV actually covers a number of pollutants, not just NOx emissions. There's a maximum limit for hydrocarbons, particulate matter, and also PM, which is the number of solid particles with a diameter greater than 23 nanometers. So again, as I said, as the notation is assigned to the vessel as opposed to the engine, the measurements can include obviously pre and after treatment systems, but it's also a bit more flexible because the testing can actually be done on board in situ. It can also be done at test facilities, but if it's all installed and retrofitted on board, the testing can also be done on board. It also incorporates the parent engine principle. So testing can be performed on a parent engine and then validated for subsequent family engines. And it also means that additional measurements are not required for sister vessels that are also the same setup. And essentially, the measurements within our rules are to be undertaken in line with ISO 8178. And for oil-fueled engines, the fuel must comply with ISO 8217. But the use of alternative fuels is also accepted. So it could be LNG, and that's obviously noted on the class certificate. Now, I've got a couple of other slides I'm going to quickly rattle through, just on a high-level overview of other projects that BV are involved with. So BV are, hang on, there we go. BV are basically leading a technical feasibility consortium study looking into operational hazards associated with using ammonia as a fuel. That's one. There's a few other studies going on with regards to ammonia as a fuel. Fuel cell technology as well. We've been involved quite heavily with fuel cell technology, and we've got some ships operating with them, such as the MSC Europa, who has a 50 kilowatt solid oxide fuel cell, which has greatly reduced greenhouse gas emissions and increased efficiency. Andy's appeared, so I better hurry up. LNG. LNG is a fuel. We've obviously recently had the big CMA CGM container ships delivered. They run purely on LNG. And again, LBG, liquid biogas. Methanol as a fuel is something as well we're involved with research on in terms of CapEx and OpEx for methanol. Wind-assisted propulsion, again, on some larger ships. We're seeing a spike in interest in wind-assisted propulsion in the bulk and general cargo markets. Again, this is more so on longer shipping routes where it can be utilised. And that's me done.
Great. Thank you, Owen. Thanks very much. If you could leave your camera on there, and if I could ask Cedric and Andy to join us as well, please. That would be great. Are we there, Cedric and Andy? Whilst we wait for them, Owen, I guess I'll start with the sort of major question related to small craft. I assume that the automotive requirements apply to all craft, regardless of size, from 2020.
Yeah, this is a question that's come up quite a bit. I think there's been a bit of, I'm not going to say rumor mill. I think there's been some different ideas bounced around. Now, obviously, it's a Tier 3 is a statutory regulation. Although we work on behalf of the MCA, we are not in a position to interpret statutory regulations. However, my understanding of the application of Tier 3 and my discussions I've had with the MCA with regards to Tier 3 is that there are no exemptions for Tier 3. The only vessels that Tier 3 does not apply to are pleasure vessels, military vessels, and some government vessels. There is nothing within the regulation that has a cutoff for gross tonnage or size. The only factor is whether you're over that 130 kilowatts or not.
Great, thank you very much. And if everyone could just mute their mics.
Yes, just to add on this, actually, there was an exception for recreational vessels more than 24 meter and below 500 gross ton. However, that exception will be lifted on the 1st of January 2021.
Great, thanks for that clarification, Cedric. And on that note, one of the things that Andy raised earlier was a concern that engine manufacturers haven't necessarily got an SCR solution for all of their range. Cedric, how many engines within the Cummins range do you have a Tier 3 solution for?
We cover today the range from 500 kilowatt up to 3100 kilowatt. On the smaller engine, it can be sometimes more challenging as an engine maker to get the business case and the return on investment. However, we are looking at this as well for the range below 500 kilowatt. What is happening is that in some instances, when you look at auxiliary genset of below 500 kilowatt, the cost element of the SCR system is quite important, quite significant to the total package. So that has been as well something that has delayed the development on smaller engine. But we are looking at it.
Yeah, thanks, Cedric. If you could just mute your mic, that's great. I think that's one of the concerns that operators will have, and Andy expressed earlier, is obviously they own 30 vessels, correct me if I'm wrong, and within that there are a number which would be potentially below the 500 kilowatts installed engine power, certainly on generators, and in those circumstances they have to, should they lay a new keel, manufacture a new boat from January 2021, fit Tier 3 engines, and obviously with their ambitions to reach net zero by 2040, they will have to refit those engines in good time. So certainly not having below 500 kilowatt solutions could pose a problem. Andy, perhaps you could expand.
Yeah, I think January 2021 is 3 weeks away. We have probably half of our fleet fit into that category. If we wanted to replace that vessel, we've actually been trying to build a vessel for some time, but couldn't find an engine green enough to install for that purpose. It just nothing that will fit in the boat So that's gone nowhere, if you like. So we're still burning fuel, which we wouldn't want to be. We're still creating emissions that we wouldn't want to be, and that's my point really. That the workboat market does start from virtually nothing right up to perhaps 1,000 horsepower or more, and we need to have something to slot into, and not just from Cummins, but from all the manufacturers. Need to get on board with that, ideally. Yeah, and I know we can't defy physics, but we do need something that's going to fit in a boat of that size. We can't change the regulations. We're left with working with boats what we've already got, or rebuilding engines, which still are not going to be compliant.
Yeah, exactly. And one of the questions that's just come in there from Martin Jackson from PME Group for Owen, really, and I think we possibly Andy Osborne may also know the answer. But with respect to existing craft, when would it be applicable to have to re-engine to Tier 3? Is that like a major refit, or
if you're re-engineering the vessel, as far as possible, you should comply with the latest tier. Now, it's a bit of it will be treated on a case-by-case basis by the MCA, because there are caveats within that in terms of if by fitting a new Tier 3 engine, practicality, things like suddenly the electrical load of the vessel goes through the roof, or the impact of fitting a Tier 3 engine has large implications. As I understand, there are situations where Tier 3 can be omitted. The other option is if you essentially fit a like-for-like engine. So if you take out a Tier 2 and fit exactly the same Tier 2, then it would be acceptable. But if you're fitting a different engine, if that engine is no longer available, for instance, it should, where possible, comply with the latest tier.
Okay, thanks for that. And on the if a vessel undergoes a major refit, and perhaps it changes from one code to another or something in that line, would that essentially sort of redefine the build date? Does that affect the tier?
There's a definition for major conversion within SOLAS, which is basically a change of the characteristic of the ship. Although these vessels don't fall under SOLAS, it may be that the MCA would fall on that definition for that purpose. Again, I think it would depend upon the scope of the conversion. If you were changing the vessel but the engines were remaining as is, it depends more on whether you're replacing that machinery or not.
Great, thanks for that. And Cedric, obviously there's a lot for operators to think about here, and I'm sure it's quite worrying for many of them. As you say, it's only 3 weeks away. What support are Cummins giving to their customers? Are you sort of assisting in packaging the SER and the amount of urea required and how it fits in the vessel?
Yeah, we leverage our different support function of the organization, the customer engineering function as well. We have some qualified service technician. Basically, what we do at early stage, we work with the design office of our customers to integrate the SCR system. There are multiple configurations available to try to make it fit. Sometimes space claim on smaller boats can be a challenge, but we offer different configurations in terms of exhaust gas entry and exhaust outlet. We validate all the drawings, etc. When it comes to back pressure or water intrusion for mega yacht, for instance. And then after, as I mentioned, we provide a Scheme A certification out from the factory, so there are not onboard testing to be done with the NOx measurement. However, our service technician will go on board to adjust the parameters of the urea injection based on the engine model that we'll install. And we demonstrate as well for some type approved application or classed application the alarms, the different alarm features.
Great, thank you. And Andy, you're obviously about to undergo a refit on one of your vessels. You haven't started it yet, I believe. What amount of rework are you anticipating having to do for that boat to fit that system in?
Yeah, okay. So, as I say, we're having to rip out the existing silencer systems. It's most certainly going to be, from a maintenance perspective, there's going to be a lot less space. It would have to be engines out to get the units in. We are fortunate that we have facilities that we can lift our own boat out and do all of that side of my own team of fitters, but to support that. But it's going to be quite a lot of work. And because they're dry exhausts, we then have to replicate the silencers, after that stage. So again, using up even more space within the vessel. So it is what it is. But the aim of this project really is to sort of demonstrate what can be done and allow other river users to see that kind of technology. So it's a positive thing. And also with that, we're going to be doing part of that project is to do the emissions testing after the event. We've done the pre-install emissions. We're going to do the post-install emissions, but I also would hope that we can compare the red diesel with the green fuel for both as well, so we can actually see what impact the SCR really has versus what the impact the green fuel really has. But it's going to be a challenge. The boat's 30 years old, so to squeeze in all this extra technology in and quite a lot of electronics into a boat that's quite, the engines are totally non-electronic. The crane's hydraulic. There's no, it's a step change, a massive step change for that kind of vessel.
Certainly a test case for you. If you can do it on one that's 30 years old, then hopefully you can do
Definitely.
it on something. Yeah. And you mentioned red diesel and biofuel there. On the engine where you've been running it and you've disassembled and obviously seen good results, have you been switching from one fuel to the other on that particular engine, or just sticking to the one there?
No, we stopped using red diesel. We have 4 of those boats. The reason we picked that boat in the first place is because it was probably our lowest cost engine, if you like. We had 4 vessels. We've got spare engines. If we caused damage, it wouldn't have a massive financial or operational impact on the operation. But we've run pure HVO from day one. We have a 4,500 litre tank, which we hired and lifted on board our pontoon next to where they would normally fuel. So that boat solely fuels from there. But there is nothing to stop you mixing that fuel. We didn't empty the tanks first. We just started mixing it in, and once we've reached the stage where we felt that it was all HVO, we did our emissions tests. They're actually delayed due to COVID, but the test facilities were shut down, and I'm still waiting for those results. But I'm hoping for something quite positive to see what that actually has done. But it hasn't had any. We've had no breakdowns. We've had no clogging. We clock up our hours. We're servicing every 5 weeks because of the kinds of hours we're doing on those vessels. So, we're regularly looking at the filters, regularly looking at the engines, and no cause for concern with that engine and that fuel at this point in time.
Excellent, and that's a UK supplier of that HVO.
Yeah, I think it's Neste.
Okay.
The actual fuel we use, and locally delivered by a fuel tanker, like a fuel barge.
Yeah. Fantastic. Great. Well, thanks very much for sharing that. Certainly, I think there's a lot of operators that are keen to use it. There's been some reservations in the last session about the safety of using it on the engine. I think your test case there is fantastic to share that with everyone. So thank you very much, everyone, for joining today. And of course, thank you very much to our sponsors, Southerly Designs. As we advised at the beginning, a recording of this will be distributed to all participants. Our next session is on the 9th of February 2021 at 10 o'clock in the morning. The topic of that session is vessel design and technologies for the future, with a focus on new hull designs. For those of you who registered to join the networking Swapcar platform, we look forward to seeing you there. If you haven't already registered and would like to do so, you can register via the booking page on your screen that you'll be redirected to in a moment. Thank you very much, everybody, for joining, and we look forward to seeing you in February.